Testing 1, 2. Ah, there we go. Hey, amplification. All right, so welcome to Graph All the Things. We're going to have a lot of fun this morning. We're going to talk about diagrams and graphs and three-letter acronyms. Hope you've got your coffee. If you want to learn about moving a data center, you are currently in the wrong talk. Please go heckle Steve in 208. SNMP can't move data centers. I had him try. It does not work very well. First, a little bit about me before we get started. I am at Refreshing Apathy on Twitter and on Slack. I picked that username when I was, I think, 11 years old and still haven't gotten around to picking another one. I am on GitHub. There's a couple things up there that you might find useful, probably not, because I basically just steal everything from Greg and Rich Troughton. Today's slides are available right now on my website, rickheil.com/PSU2016. So if you're the type who likes to follow along with slides as you take notes, feel free to grab the PDF from there right now, and that'll help things out a little bit. Those slides will also be available through the rest of the conference. If you want to record or live stream, anything like that, go for it. I don't have a problem with it. And we'll have about 15 minutes or so for Q&A at the end. So jot down any questions you have as we go, and we'll try to get those all addressed as soon as we can at the end. A little bit about me. Work-wise, I am half of the IT team for Partners & Simons. We are an integrated marketing and advertising agency in Boston, so go Red Sox. We specialize and have a ton of experience with health and wealth clients. So that's a lot of insurance plans, health organizations, doctors, nurses, hospitals, insurance companies, financial services and products companies. It kind of puts a really different compliance standpoint from most advertising agencies that you'd get. A lot of creative agencies tend to be kind of the Wild West, and we've got a little bit of a different attitude towards things. At the same time, we focus really heavily on helping our end users get everything they need to do done, and they don't necessarily have to ask us. Now, obviously they do, or I wouldn't have a job, but we want to make it easy as possible for them to do things. We use Monkey and Meraki's MDM in production to manage things. We have about 100 employees. We are growing fast. If you are from Atlanta or Chicago or Boston and you're a copywriter or an art director, see me afterwards, because we're hiring. And I like referral bonuses. And I am also a musician, like playing guitar and keyboards. I cook a lot in those weird sciencey ways with those like powders and stuff that you've never heard of before. It's still delicious. And I also ride motorcycles a lot. So if you see me on your way home, please wave. I rode here on that from Boston. It was a lot of fun. I promised Brian I would put at least one pie chart in here of the pie that I have consumed so far. This represents all the desserts we've had. They've all been delicious. Thank you to the team. Let's talk about what we're going to talk about today. First, we're going to go through alerting theory. Why do we monitor? How alerting benefits your business? How to make effective alerts? Then we'll dive right into the simple network management protocol, SNMP. We'll talk about some basic terminology. We'll talk about functions. We'll talk about overview of how it works as a system. And I'm going to assume that you've never touched SNMP before. You might have heard the acronym a couple of times, and maybe you've played with it or read a blog post or two. But this is all very basic, entry-level stuff targeted at anybody. So you should walk out of here with a basic understanding of how to get data to and from your systems with SNMP. We'll run through how to make a configuration file for SNMP. OS X has a brilliant built-in tool for generating them. So we'll give a little demo of that. We'll talk about Observium, which is the network management tool of choice at Partners & Simons. We'll give a little walkthrough and demo. It kind of creates amazing graphs and takes a lot of the guesswork out of adding support for new devices that we have on our system. And then finally, as I said, we'll have about 10 or 15 minutes for Q&A. If you have questions that come up after the session, find me. I'm going to be here all the way through the end of the conference. And we'll try and get those answered for you. So let's dive right in. How urgent was the last problem that woke you up? Or maybe interrupted your dinner, or a date, or a movie, or something like that? And should it have interrupted you? And did your alerting wake you up? Or did a user wake you up? There are certain outages I hate hearing about first from our users. One of those is email. Drives me nuts when someone comes over to my desk and said, hey, yeah, did you know the email server's down right now? And I said, no, my monitoring hasn't. And it clicks, oh, man. So what's the solution to not finding out about outages from your users first? Monitoring and alerting. So why do we monitor? Other than the obvious, well, so we know what's going on with our infrastructure, which is kind of self-explanatory, I have some boardroom bullet points that you can use to sell your executives on this investment. The first one is that it enables proactive problem solving. So instead of waiting for a ticket to come in or a user to walk over to your desk, you get an alert or a notification that says, hey, something's broken. And you say, I'm the IT person, I get to go fix something. You can catch that problem before it becomes a production issue, usually. The second is that it does enhance your security because you now have historical data. You get to analyze and look at trends in your data, whether that be networking, whether that be disk usage, whether that be CPU usage. You have some idea of what your system is doing, and you can look backwards without a time machine. Super helpful. Support time. Time is money. I hope we all get paid here. The extra 5 or 10 minutes that you might get from a good alert is enough to get a fix in progress before those tickets start flooding in, before you have a bunch of people coming over and yelling or your phone starts ringing about an outage. That 5 or 10 minutes can be the difference between a quick fix and then you go get a second cup of coffee or your whole morning being blown. And lastly, you get to look at pretty graphs. They're pretty. I like graphs. This is an example. This is a network graph from our Monkey repo. You can see which day we pushed out our Office updates this past week. That's outbound traffic on the bottom. But setting up monitoring comes with some inherent risks, and not necessarily even the security ones, it's more your sanity. When I set up my first network monitoring system for a freelance customer, it was louder than all of my motorcycles put together, just a torrent of emails. I'd have 30 or 40 messages before breakfast, and at some point, the balance flipped from alerting to just spam. It was overwhelming because it just took up too much of my time. I had syslogs coming in, I had traffic reports, I had usage summaries. All of this stuff was just noise. When you need to make a filter to take alerts out of your inbox, you're probably over-alerting. And that can be just as bad as under-alerting. Because what a good alerting and monitoring system should do is filter the noise for you. Because otherwise, what's the point of having it? You can just log in, look at your tool, and try to figure out something from the data. The point of this being automated is you don't have to think about it. It should do that for you. Too many notifications waste your time, and again, therefore your money. You're less likely to pick those problems out by yourself if you don't let your alerting system do that sorting for you. Don't fall into the trap of needing to alert for every single little thing. How many people use Slack in here at work? Okay, a couple people. Do you provide support over Slack? No, a couple maybe. If you don't, why don't you? Probably because it's super noisy, right? It's this constant on. It's like when someone finds your personal cell phone number and texts you at like 10 o'clock every night asking you work questions, and you're like, I like you, you're a great coworker, I'm trying to sleep. That's, again, the problem that we need to avoid with our monitoring and alerting system. We need to make sure we don't fall into that trap that we needed the infrastructure to reach out and say, hey, I'm doing this, now I'm doing this, now I'm doing this. The point of alerting is emergencies and urgent notifications. So I'm sure you're sitting there saying, well, how can I streamline my alerts? Well, you're in luck because we have a 4-step alert test to create a good alert. We're going to go through all of these in detail in just a second. Number 1 is the alert impact-based, or does it have a really clear reason to be cause-based? And we'll talk about the differences there. Number 2 is the alert actionable. Does it prompt you to do something? Number 3 is the alert threshold reasonable. So have you set that alert to kind of fire off at a good time? And number 4 is the alert notification targeted. So let's go through those. First, we'll talk about cause and impact-based. Does a user care that CPU core number 2 out of 8 is spiked at 100%? Or do they care when their SQL queries are slowing down? Most times, it's going to be the second one. Cause-based is great information for us, for IT people. It's statistics, it's hardware information, it's that hard data that's sitting there on a graph in front of you. Impact-based is great for what we don't always do as IT people, which is consider the other side, which is the user experience and how they're interacting with your application or your service. Impact-based data generally comes from monitoring something about that end user experience, whether that's SQL query execution times, process status, system load, maybe response time for loading a web page. All of those things are important, and both cause and impact are really important for problem solving. It's tough to do it with just one of those two. However, alerts that are cause-based lend themselves to over-alerting. If you're alerting based on CPU metrics rather than, oh, my application is being slow, you're gonna get a lot more false alarms just from a momentary spike that your monitoring system might freak out about. When you're setting up a new alerting scheme, the biggest consideration is which system should be cause-based and which can be impact-based. So let's take an example. Let's do a monkey server. So really basic, Linux, Mac, what have you, and all it does is run an Apache web server or web server software of your choice. What kind of things would we want to monitor? Ideas? Disk space, perfect. So you know, are you running out of stuff when auto package is just dropping new updates in there? What other kind of things might we want to monitor? Network, sure. So the graph that I showed before, is there enough network availability? Am I saturating it when I'm pushing out some really big, hefty update? What other kinds of things might we monitor? 404s. Sure, 404 pages. So we might say, you know, is something with our Apache configuration completely messed up, and when we try to hit the main catalogs, it gives us a 404. Any others you guys can think of? So things maybe like CPU usage, RAM usage, maybe not just 404s, but even more detail about Apache and what it's doing. Disk health, for instance, you could monitor smart status, which kind of gives you an idea of whether the disk is healthy or not. So what are some of those cause-based alerts that we just talked about? So that might be CPU. That might be disk space. That might be disk health. These are hard metrics that don't necessarily have anything to do with the end user experience. An impact-based alert, a 404 error on a main page, perfect. That's something that when a user pulls up the Managed Software Center, wants to install whatever widget that they need to self-service, and you hit install, and it gives you that the Managed Software Center has encountered an error, and you go, oh man, what is that? That's the kind of thing that we can use as an impact-based alert. You can see how both of those will give you good insight into what your services are doing. You need to monitor disk space, because otherwise you run out of disk, you're going to run into performance problems, your updates aren't going to push through. But you also want to make sure that your clients are able to reach what's on that disk. I mentioned the word actionable, which is number 2. An alert should never be an FYI. It should not be a notice that thanks you for noticing, and your noticing has been noted. It should be something that you can look at and say, okay, I need to perform an action, whether it's my disk space is full, I need to clean up some old packages and kind of empty the trash and all that usual stuff. Alert should notify you of a problem to solve, either right now or sometime in the future. And when planning alerts and creating them, this is something you can think about to get some idea of that cause and impact based and your threshold, which we'll talk about in a second. Actionable depends on a couple different things, and it also relates right into the threshold. Part of that is knowing the workload of what you're doing. We don't monitor CPU on our Monkey server because we don't need to. It's a relatively new Mac Mini. It's running something super, super light. There's just really no need for us to alert based on that metric. We do alert on things like, is the Apache process running? What's our available disk space? With that knowledge of your workload of the system, you can give yourself enough pre-warning to address a problem before it becomes critical. So let's say we monitor all of our printers, and it tells us about toner. My threshold for toner is about 5 to 7 days before it hits 5%. Why is that? Because it takes a week for me to order toner. It stinks, but that's kind of how it has to be. But that's an actionable alert with a threshold that we picked out after we analyzed our workflow. We said, it takes us a week. Let's alert at 10%. It gives us plenty of time. That way, when we get the 1% alert, all we have to do is go to the closet, slap the new toner in, and we're done. Something like a web server running out of disk space, you might set a different alert. You might set something because you know I can fix that within an hour or two. You can kind of bump that threshold up a little bit so that you're not constantly going back and fixing, going back and fixing, going back and fixing. The key here is to not let your monitoring cry wolf. So if you set a low threshold, you're going to constantly get the same alert over and over and over and over and over again. You don't want to be alerting yourself so early. You go back to that spammy kind of alert fatigue situation. And don't be afraid to use a little bit of trial and error with this. Always going to be a little bit rocky at first, and you'll kind of figure out exactly what you need to know and when you need to know it. The last of the 4 steps is the notification targeted? We have a sister company in Chicago, and if I get an alert for something they take care of that I don't even have a login for, did I really need to get that alert? Keep the number of people who need to get each alert to a minimum. And I know some people, you might be the only admin at your shop. Well, sorry, you gotta get all those alerts. Or maybe you have a policy that everyone on the team gets alert, or everyone's on call all the time. Adjust that to your shop as you need to. If you're not solo, some sites like PagerDuty and such can help kind of distribute things on a schedule, so that way everyone kind of gets a night off. But again, we're looking to reduce that alert fatigue, reducing frequency and only giving alerts when you really, really need to action something. So to review this first section, we monitor information, makes us more efficient. Historical data is a huge benefit to pretty much every process you can think of, and alerts need to be configured properly to avoid that fatigue. And if you wanted to take a screenshot, there's that 4 alert test again. And now, the fun part. Simple network management protocol. It may not be the most simple thing in the world, but it is very, very widespread. Pretty much anything that has a network port and some kind of pseudo-modern operating system will probably support the simple network management protocol. Anything that has enterprise in the name or that you buy from an enterprise company like Cisco, it's going to support it out of the box. So what does SNMP allow us to do? Well, it allows us to do 3 basic things. The first is that we can pull data out of it. That's P-O-L-L, pull. The second is that we can write data into it. And the third is that it can send us notifications out. So it can kind of, on its own, say, I've met a threshold, here's an alert. So let's get started by doing a little bit of terminology. I've got a very advanced graph. You can tell that I'm the IT guy and not the graphic designer at our agency. The first word that you'll see a lot is community. A community is a group of devices sharing some sort of commonality that you've assigned. So whether that's they're on the same VLAN, they're physically in the same location, they're the same type, so they're all access points or switches or laptops. However you kind of want to architect it. This plays into setup and a few of the security items later, but a community at its core is just a group of devices that you're interacting with. There's a manager, which is inside the community. That's responsible for retrieving or pulling data from the devices and sending information to the managed devices. And lastly, there's our agent. It's a software that runs to translate that management protocol data into outbound information to answer requests or configuration changes locally. Now, it's important to note, agents are software, not hardware. There are some really complex setups you can use with multiple agents and do all sorts of cascading tree kind of things. We're not going to cover that today, but when you see agent, remember software, not hardware. Every agent, so that piece of software, maintains 2 sets of data. Management data, that's the actual values that we're talking about. That's the configuration value. That's what the system's host name is. That's how much traffic has passed back and forth over an interface. That's the CPU load. Those are all labeled by object IDs. So an object ID is just kind of like the key, and then the value is your management data. And then there's the management information base, which is an MIB, or MIB, which is like an index that describes those OIDs and gives you a little more information about them. This is really weird, so what I'm going to do is just show you an excerpt from one of the standard MIBs. This is RFC 4022. If you're really bored, read that tonight. It will put you to sleep in about 15 minutes. But it's a great example. So let's see, is this a laser pointer? It is. So up here, TCP-HC insegs. That's the name of our OID. So on this system, we can read our description here and see that if we ask over SNMP for that OID, we will get the total number of segments received over TCP, including any errored segments. That's it. So this whole thing is a piece of a MIB. That TCP HC insegs is an object ID. And then we've got some other data about what kind of it is. So it's a 64-bit counter, it's read-only, it's currently implemented. So this is just a piece of a MIB. So MIBs are pages and pages and pages of exactly this. They are human readable, if very boring and kind of difficult. There are MIB reading software. There's a lot of free ones out there that you can kind of page through if you want to see. These are like the dictionary of what values your system can pull and push back and forth over the simple network management protocol. A little bit more about OIDs. OIDs are unique and linked to a specific piece of data as described in that MIB. So you're not going to see another counter for the amount of TCP traffic coming in. That's it. It's just that one. There's two types. There's scalar OIDs and tabular OIDs. Scalar, if you've done any program, this is pretty familiar. Scalar means that it's one value, so it's a number, it's a text string, it's an email address, it's a configuration key. Tabular OIDs are an array, so you can represent kind of a table of things in there. So that's useful for things like CPU usage on like a multi-core processor. And all of these OIDs are organized in a tree format to kind of group them and categorize them. So your MIB is going to read from top to bottom in a tree, kind of like an org chart. And I've actually got a sample one here, which will help you kind of visualize it. So at the very, 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 very top of this particular tree is the ISO, which is the International Standards Org. So that's the very top branch. Next one down is the organization branch, then the DoD branch, then the internet branch, then the management branch, then the system branch. And then at the very bottom, you've got 1 through 7 there. Those are our actual OIDs. So you can say, all right, I want the system description, which we as administrators would fill out. I want the uptime, so the time since last boot. I want the name, the location. Number 7 is a tabular OID, so that just gives a list of all the services that are running, kind of like PS or TOP would. So that tree allows you to kind of organize and figure out where things are. And you'll see you can kind of represent these in two ways. There's not only a text way, which is kind of similar to how preferences domain is named. So it's, iso.org.dod.internet.management.system.sysdescription. Or you can also use numbers. So the numbers, for example, if you look at the third bullet point there, 1.3.6.1.2.1.6.10.17, flows off the tongue really, really well. There is a great utility called SNMP Translate that will let you take either numbers or the text version from the MIB and switch them back and forth. Now, why are there numbers? There are numbers not because they wanted to make this the world's most complicated phone IVR system. There are numbers because it's programmatically really easy to walk down a tree. So for instance, when you do a get, which we'll talk about in a second, and you say, I want the system description, you tell whatever program or script you're using, all right, start at the very top of the tree, take the first option to go ISO, then take the third option to go org, then take the sixth option to go to the DoD, then the first option to go to internet, et cetera, until it drills all the way down to, say, number 4, which is syscontact, which is your email address. So in some ways, it's kind of like giving turn-by-turn directions to your script or program that's getting that data out. It's a lot easier to reference that way than to have to do all sorts of weird text parsing and kind of try to figure it out. Keep in mind, this protocol was made a very, very long time ago. So this is before standards like XML were around. So this was a lot easier to parse in a scripting way. Now let's talk about the 3.5 SNMP methods that you'll need. So this is how we're actually interacting with the agent. A manager can get information about a managed object, very similar to how HTTP works, so it could pull that information from the agent. It can also get next, which basically says whatever's next in the tree, just go down that piece. I don't really care what it is. There's set, which allows the manager to push a value to the agent. And then there's trap, which allows the agent to push backwards to the manager and say, hey, something's going on, there's an alert, there's a condition you need to know about. There's more methods than this. There's about 10 in total. These are the 3.5. I call get next to half because it's basically get with a little bit extra. Those are the 3.5 that you'll need to get started. So again, we've got a manager, get to pull information from the agent, set to push information to the agent, and trap, the agent can send information to the manager, kind of unsolicited. Now I'm sure you're thinking, oh, trap, that's our alert, right? No, I thought that too. Doesn't work that way. The simple network management protocol is all over UDP. So what does that mean? It means there's no guarantee that your packet with the trap will get from point A to point B. And the last thing you want is, let's say your trap is about a saturated interface on your core firewall and all the routing is all messed up. Well, that UDP packet might get dropped. You might not get alerted. So most network monitoring systems are going to use that get and analyze the data internally to figure it out rather than trap. Trap can be super useful, though, for certain conditions. So, for instance, we have trap set up on our UPS units to send us an alert when they go on battery power or when the battery needs replacing or there's a brownout condition, things like that. There is a very useful tool for discovering all of this, and you can actually play with it on your Mac. It's pre-installed. It's called SNMP Walk. And what it does is it walks using get next from the top of the tree all the way down to the bottom. You can actually see an output of all the data available from a device, all the configuration options you can make. It's super, super, super verbose, very, very long amount of scrolling. It's usually like 6,000 or 7,000 lines. But a little bit of filtering and some command F, you can kind of figure out what kind of groupings of things you can see. So let's actually give a quick demo here. And gotta drag that over to here. And we'll make this a little bigger so you guys can actually see it. And we'll go through some of the syntax with this later. If it is, oh, actually, you know what? I changed that last night. So these are all the things that SNMP is touching on my system right now. You can see there is a ton of it. There's more. It's still going. So for instance, you can see the host resources thing. That's talking about all the different processes that are running. You can configure that based on the person and based on the machine. You can talk about different run indices. You can say, okay, it's connected to these IP addresses. There's those TCP counters that we talked about that monitor bandwidth. There's CPU. There's all sorts of crazy stuff. And it's, this is all just a ridiculous amount of data, which is why we need those SNMP tools to kind of tell us what's going on. Because if you had to look at that every time you had a problem, you'd never solve anything. So to review, data is labeled by OID, organized by MIB. MIBs are laid out in a tree format. A manager gets the content of an OID to pull the data out, sets the content of an OID to alter configurations, and traps to the manager to alert with information. And this is a cute picture of a cat because that last session was ridiculously dense. I'm actually going to break my original plan and ask who has an immediate question about that SNMP, because that's a lot of information. There's a lot of things to digest in that. Any standouts so far? Nothing?
That walk you did was on your machine?
The walk I did, yes. So the question was the walk I did. That was on my machine. So I have an agent running locally on my laptop for this. And all I had to do was say, this is the community I'm part of. Start at the top of the tree, go to the bottom, and the agent says, all right, you're authorized for that. Here's all the data for you. Which actually leads to a great question, which is versioning and security, which is what we're going to talk about next. Any other quick questions before we go to the next piece? All right, cool, let's do it. So there are 3 different versions of the protocol. Like I said, this is a really, really old protocol. Version 1, very basic. It just takes that community string. So let's say you have all your switches on one community, and your community string is switches. I don't know. When the master, the manager reaches out to your agents, it'll say, hey, I'm part of the community called switches. Please send me this information. The agent will then compare that community string and say, yep, you're from an allowed IP address, and you're from an allowed community. Here's the information you have access to. And you can control, through the configuration files, what it has access to and what it doesn't have access to. The second version was v2c. You'll sometimes see it just v2, v2c. They're essentially the same thing. The only difference between the first and the second version is that version 2 added support for 64-bit counters. The problem with version 1 and modern technology is that a gigabit Ethernet interface can overflow a 32-bit counter in about 33.5 seconds. So if you're not polling every 15 seconds, well, you're losing data, and that's not good. So upping it to 64 lets you kind of capture more data as you're going. Now, there's 3 different kind of subsets of version 3, and this is the one you mostly want to use in production. Version 2C is great for home labs. It's great for kind of tooling around on your laptop, but the only security is just a plain text string. So that's something that someone can guess or brute force relatively easily if you don't have some really advanced firewalling going on. So version 3 has 3 versions. It has a no authentication, no priv, so auth is authentication, priv is privacy. That first version is essentially the same as the first 2. It's just a plain text username, that's it. If it matches, you get your info. The second version has an authentication. It's a MD5 or SHA hash over HMAC. And what that does is kind of actually does a little bit of authentication, harder to hack into, harder to brute force, a lot more secure. But the problem is you're still doing a plain text stream. So you're still just sending your data back and forth in the clear. Now, for sometimes, like a home lab or just kind of messing around, it doesn't really matter. But you're not going to want to send your production data, especially if it's over the internet, in clear text. It's just not a good practice. So we have version 3 with authentication and privacy. Uses DES keys, so you put the key on both sides. Remember, this is UDP, so they can't do like the fancy key exchange like, say, an HTTPS website would. Going to put the key on both sides. It encrypts it on one side, sends the data stream over, decrypts it on the other side. Boom, you've got your data still, and it's secure, and it's not going to be intercepted by prying eyes. Most times, version 3 is what you're going to want to go for. Some older devices may not support it. Some embedded devices may not support it. We had an older UPS that just didn't have it. V2C was the best we could do. Make do with what you can, but most modern stuff is going to support version 3, which is really where you want to go. So security-wise, what are we going to do? Well, like we just talked about, you're going to try your best to pick the right version to implement. If it's something that's low security or at home, 1 or 2 is going to be fine. Production, you want to go with 3. Set up your community access list to only allow trusted addresses. So you can say, well, my network manager is at this host name or this IP address or in this IP range. Only allow connections with this community on these hosts. So that kind of locks it down a little bit, kind of adds a whitelisting function. But it's also not a bad idea to add ACLs on a firewall or a firewall locally or at the network level to kind of crunch that down just a little bit further. You want to try and avoid someone who can get to your network and, say, spoof or reverse DNS, and then all of a sudden they've got all your management data. For read-only stuff, this is a little less of a problem because it's just read-only. So the worst thing they're going to find out is, your monkey server has 20% disk left. For write access, that's a big, big security problem. You want to lock that down as much as possible. Most of the major switch manufacturers, Juniper and Cisco, they're all going to let you alter configuration data using this protocol. Now you can make read-only communities, but if you're using read-write, you really want to make sure you've got your security, your ACLs, and your firewall really locked down. And Cisco actually has a brilliant white paper about this. There's a link that I'll put at the end of the slides, and it's also on my website. The configuration examples are really geared towards their operating system for their switches, but the principles are super, super handy. All right, here's the hands-on part. Let's make a really easy, simple network management protocol config. So we're going to use the terminal app because we're hackers, right? And I'm going to make this full screen. I'm going to zoom it in just a little bit more. All right. How's that size-wise? Is it all right? A little bit bigger? All right, cool. So the command is just snmpconf. That's it. And what it is actually on the background. It's just a Perl script. And what it does is it walks you through each level of the configuration file, describes the options a little bit, and kind of helps you through what the default options are and explains them a little bit. If you've ever configured things like a UPS or a PDU over like a console or serial cable or like an old telnet interface, this is going to look really, really familiar. Now, this first screen is going to be different for you. I have some configuration files that I've already kind of written in. So usually you would say read in all the configuration files if you're making a change. Otherwise, you can just say none. It'll start you with a blank template. Now you can see there's 3 configuration files here that we can kind of mess with. One is the SNMP trapd conf. So that's going to tell the agent, okay, what are my thresholds for sending a trap to the manager? What am I going to use as criteria? What am I looking at? Where should I send things to? All of that. There's the snmpd.conf. That's the actual agent's configuration itself. So that tells the agent what community it's part of, which hosts it's allowed to talk to, whether or not the community is read-write, and some other cool things we'll get into in a second. And lastly, the SNMP conf. That's actually a manager conf. We're not going to talk about that one for now, just because it's a little more complicated. It's a little beyond the level of this. So let's choose number 2 on here. It might be different for yours. Let's make an SNMPD conf. And you can see we have 5 different options. We have some authentication. We have formatting, logging, runtime, trap handlers. We're going to go for authentication. Oh, you know what? I think I picked the wrong one. Of course. I want SNMPD. There we go. All right. I was making an SNMPD trap by accident. So this access control setup is where we want to go. And this is where you'll see we have these options. We can create users for both version 3 and version 2. We're going to make a version 2 read-only community name, so we'll pick that one. And let's call it PSU Mac. Now you'll see right away it prompts you what hostname or network address can this community use. Now if you're in a home lab, you can just hit enter and allow pretty much anyone. If you're in production, what you're going to want to do here is enter either a hostname, so monitoring-system.yourcompany.com, or an IP address, or something that tells the agent only accept communications for the PSU Mac community on that one hostname. So I'm going to say 127.0.0.1. I like you guys, but you're not getting access to my stuff. Okay, the question was, can you put a subnet in there? Yes, this is CIDR notation aware, so you can put pretty much anything you want in there. So if you have an entire group of SNMP managers, or if you're pushing configurations back and forth between devices manually or something, you can allow a whole management subnet if you wanted to. Great question. The next option you'll see is the OID the community should be restricted to. Now, for this demo, we're going to say everything. So that's going to give you that massive list that we saw in the terminal a few minutes ago. You can actually say, you know what, I only want to have this community have access to this one little section of the tree. So you can say, all right, well, this management tool should only have read access to uptime, but this management tool should have write access to this specific configuration. So again, you can kind of segment it just like you would user accounts into groups, do it based on least privilege, and figure it out the best way that works for your org. For now, we're just going to leave it blank, and that's it. So what we've just done is we've set up our daemon to say, all right, anyone who comes from localhost and has the PSU Mac community name, give them access to any of the data they ask for. Now, if we type in finish, that kind of goes back up a level, and you'll see that we can monitor specific aspects of the host. So that comes into listing things like processes and usage statistics about each individual process. We're not going to touch that today. It's a little more complicated than we have time for. We have an operating modes that tells it what kinds of services run. Again, this is something you can read about on your own. It's a little bit beyond what we're talking about today. Let's also go to the system information setup. And what you'll see here is the first two that we care about, the location of the system and the contact information. So my location is on the podium. All right, and contact information, I am going to put my email address in here and hit finished. You can also set trap destinations from here, so that'll tell the agent where am I sending traps so that it's aware of where your manager is living on your network. And once you're all kind of happy, you can kind of go through and double check your options. Once you're happy, you can press finished and then do quit. Now, in this case, I already have one that I did last night, so I'm going to hit skip there, but it would just save. Now, when it does this, it's going to save that example configuration that you just made. It's going to save it into whatever your current working directory is. So by default, when you open terminal, it's going to go into the top level of your home directory. So if you go in there in Finder, you'll see there's an snmpd.conf file right there. And you can open it up, and you can see that we've got a lot of different options that we've just configured here. You can see we've got our sys location there, which is on the podium. We've got the contact, which is my email address. All sorts of good stuff there. Now, if you'd like, you can actually run this really quick and kind of play it around. You can launch the SNMPD daemon with the -C switch, which tells it to read configuration from a specific path. So if you want to test locally but don't want to have to load and unload a launch daemon every single time, which I admit does get to be a bit of a pain in the butt, you can go right for here. And as soon as you do that SNMP walk, and we're going to tell it, all right, we're going to use version -v 2C, that's what we set up, -C, so what's our community name? It's PSU Mac. Where are we looking? Localhost. Ooh, if I could spell SNMP walk, we'd be in good business. And you can see that's going to start spitting back all the stuff that we allowed it access to, which in this case, literally everything. You can also see there's the default location for this, if you're going to run this on, say, a Mac server, is in etc snmp snmpd.conf. Of course, it's not going to load. There it is. So here we have an example of a community that has an OID restriction. So the public community, all that's being allowed to do, well, I actually don't know what that one is. So let's use our SNMP translate command. Wrong one. -to. And that says, oh, okay, the syscontact. So anyone who has access to the public community, which is a pretty standard thing, can see the email address that I've put as the contact. Now, that may work really well for you, or you may say, oh God, I don't want that. So you can comment that line out, you can delete it, you can even say they have no access at all. The rest of this, again, is things that we set, things like the location, things like the administrator value. There are about a dozen more options that live in those menus in that configuration script that we're not going to cover today. Feel free to poke around with them. And when you generate that config, you'll see that it has that big, long block of explanation about what each piece does. That's going to be both in the tool as you create the config file, and it's also going to be here in the finished config file. So you can kind of play around with an option, go into the config file, read what it does, adjust it, run SNMP, see what it does. This is really useful to have built in on a Mac because you can just play with it, see what you like. If I can get to the other screen. One quick aside here. There is a multitude of MIBs for just about every piece of enterprise gear you can think of. Most manufacturers are going to provide one, usually for free. Some places make you have like a warranty package to be able to download it. But those are going to be kind of your dictionary, your Bible, to see what kind of information you could get in and out. But there's some information that you're not going to be able to get out because it's not included in that MIB. So let's say on OS 10, I want to get some information about the web server. So usually what we do is we do this, you'd either open up the server.app and go to the statistics, and there's some pretty graphs there, or you could go to your terminal and do server manager and get web status and all that good stuff. In your configuration file, one of those options is to extend the agent. And extending the agent basically means making it do a trick that it usually wouldn't do. It leverages a special MIB that's built into the agent called net SNMP extend MIB, really useful. What it does is just says, all right, if I get a request for this OID, I execute this script. That's it, really easy. So for example, a line in the configuration that says exec OS version and a path to an OS version script with a script that just does SW_version and greps through and just prints a version string and then exits, gives us, when we SNMP walk, a string that says 10.11.5 because that's the version of the OS that I'm running here. You can do that with a web server status. You can say running or stopped. You can do that with how many times something's been rebooted in the last week. You could do that with how many files there are on the desktop. If there's a script you can write and there's a way to output it either in a scalar, so just a string like that, or tabular in a table, you can monitor it. Not every management system is going to be able to interpret these really well. The one that I prefer, Observium, does, so we use it. But most will have at least some way to do this. And because SNMP is included on pretty much everything, and there's a library for pretty much every scripting language, you can even write your own little programs or applets to monitor things specific to your extensions. There is a really important security note on this, which is that when you look at how the simple network management protocol runs on OS X, it's running as root. So that means anything root can do, which is anything, your script can do that too. So again, you want to make sure that your script is safe. You want to make sure it's not trying to take parameters from your GET request, because that's another vulnerability. That's an easy way for an attacker to be able to inject something and do something nasty. And you want to make sure that your ACL and your firewall and your communities are locked down as much as possible, especially if you're doing write access. So to review, use v3 with authentication and privacy whenever possible. It's going to be the most secure way to do things. Firewall and ACLs are best, as well as the host and IP range configurations that we talked about in that file. SNMP conf will walk you through those configuration files. Extend is freaking awesome. And there's no cat on this slide. I failed. And now on to the fun thing, which I'm sure you'll hear about, which is graphs. There are a ton of different management software options. There's open source, there's closed source, there's paid, there's free as in beer, there's gratis, there's Libre. There's a million different versions that you can pick up. Cacti, Xenos, SolarWinds, Spiceworks, OpenNMS, Observium, all of these are going to do the same basic kind of thing, which is they're going to take information from your agent and present it to you in a nice way. Now, depending on the feature set and the budget, you're going to pick something else. If you want something cloud hosted that you don't have to manage or really do that much tweaking to set up, some of the hosted platforms like SolarWinds or Spiceworks are going to be great for that, especially if you already use something like Spiceworks for other stuff. Spiceworks also does things like inventory, which can be super, super useful. We prefer Observium because it's self-hosted. That's something that a lot of our clients require. Remember, we have some weirder client requirements because we talk with people who have boatloads of PHI and PII. It's written in PHP, for better or for worse. It means that I can log in and I can modify it. When we started using Slack internally, Observium only did alerting by email and no Slack. So I spent an afternoon and hacked some Slack integration into it. And that code actually got repurposed upstream and kind of cleaned up from my initial hacking implementation. And now it supports Slack and HipChat and all these other messaging apps. And it does a few things and does them really well rather than trying to be kind of your total solution. There's definitely something to be said for the single pane of glass, but in my opinion, network management software is not the place to try to achieve that, unless you're Meraki, in which case, go for it. Let's do a demo. So this is going to be a snapshot of the database from our production Observium instance with a couple of small changes. So what you'll notice is that there's probably a ton of different alerts on it, simply because it's not able to reach anything right now, so it's freaking out and thinking that everything's down. Let's make this full screen, and let's zoom in a little bit. So on our homepage, simple map, that goes off of that syslocation string. So if you put an address or a city and a town in that syslocation, it'll map everything, just like, say, in some of the more popular MDMs might. And it'll give you green for up, red for down. We have our menu across the top. We've got our alerts at the bottom. Like I said, it's freaking out that everything's down. Everything's down. And our change logs. Let's go right to the fun stuff. So in our servers, let's go for our monkey server. All right, so in our monkey server, we can see all of the different things that it's currently graphing. Now, the way Observium works is you add a device and you say, okay, this is the device hostname, this is the community string or the username and encryption key to use if you're using v3, and it does something called auto-discovery. Now, what does that mean? That means everything I've talked about for the last 40 minutes, you don't actually need to know. It just does it all for you. It reaches out and says, okay, well, I can tell from all of the sys descriptions, okay, this is a Mac OS X server, cool. Mac OS X usually supports these MIBs. It'll ask for that information. And it'll say, okay, what other stuff do you support? There are a ton of different supported devices of a lot of different brands. So pretty much the who's who of network hardware, the who's who minus Aruba of wireless hardware, security devices, servers, appliances, workstations, even base OS. We have a QNAP storage unit that we use as a network attached storage. It's got specific, it supports specifically that MIB. Now, what if something isn't supported? Well, there's these things called generic MIBs. Like, remember that TCP one? That's kind of a genericized standard that everyone's going to implement the same way, pretty much regardless. So on Monkey, there may not be a specific OS X MIB, because Apple doesn't really publish anything specifically, but it can use kind of those generic bits to piece together the things it can monitor. So for instance, we have processor usage, memory, storage, ports, all that good stuff. For both Linux and Mac, you can see we also monitor Apache. So I can look at things like bits transferred, hits. The scoreboard is errors. So that's where we can pull our 404 error metrics out of. Pretty much anything you can put into SNMP or into a separate thing Observium uses called an agent, just a little Unix script that pushes additional data. Anything you can put in there, Observium can graph. Let's take a look. Actually, one of the really good examples is one of our server PDUs. This isn't something, Triplight isn't officially supported. But again, what we see is that it's still grabbing what's the source of power, what's the input and output voltage, what's the frequency of the power that it's getting. And the reason it's able to do that is because there's that standardized power MIB that Triplight uses along with everyone else. We can also look under the power category. We can look at one of our production UPSs. So right now, we're having some problems on our office where we have like 15-minute brownouts about once a week. And you can see right here, this is alerting that there is on Smart Boost, which means that the power is down just a little bit and the battery's bringing the level up. So that's probably why my phone was freaking out earlier. It'll also say, okay, is your battery still good? I mean, who's left the UPS battery in for too long and it starts like seeping liquid onto the bottom of your server room floor and you feel really bad? Yeah, we used to do that a lot. Not anymore because it actually tells us, hey, your battery's going bad. And we can even see things, specs directly about the battery. What's the actual voltage? What's the input and output voltage? How much runtime is there remaining? So we can even monitor and say, all right, I know APC has a metric for when the battery needs replacing, but what if our SLA requires more than that? We could actually monitor as soon as runtime gets under 15 minutes, that's when we need to replace that battery. So this flexibility here is fantastic. Let's talk about everyone's favorite, printers. Show of hands if you hate printers. Yeah, everyone. We have reduced the number of calls about printers, printer toner, pretty much everything except for really nasty paper jams with this system. One of the beautiful things, so you can see we have a bunch of different printers. Our lunchroom's under construction right now, so those are down and ignored at the moment. But if we go to health printer supplies, we can actually see from one page how much toner is in every single printer that we deploy. Every single one. And this is not only, I mean, so this one here, it's a HP CF280X cartridge. That's just a little home office multifunction, like print, scan, fax kind of thing. It's not an enterprise printer at all. It's still a laser. Pretty much if it's a laser jet, it's going to support the simple network management protocol. Inkjets, 50-50, plus those are more costly than human blood for ink. Probably don't want those in production anyway. But we can actually alert on this and say, okay, you know what? We're running low on toner. Let's get that. You can see our copiers even have fusing unit status, waste toner, bottle status. We can order our supplies. I can walk in the morning and have an alert and says, hey, waste toner bottle on the big color printer is full. I'll empty it before anyone even gets to the office. I can enjoy my coffee in peace. There was a question there?
Can you monitor the number of print jobs or the total number of paper that have been run through?
Sure.
Or
So the question was, can you monitor other aspects about printers? So say number of print jobs, amount of paper in the trays, when other supplies are getting low. The answer is kind of. It depends exactly on the MIB. So we're going to go back to that and say, so our big color printers are from Ricoh, and their MIB, it does not expose paper or staple level. It does expose toner, waste toner, number of print jobs queued, how much paper, like how many clicks, so how many pages have been printed. Those don't get exposed. So that's where you can say, I'm thinking about a new printer model to replace maybe like all of our stuff. That's where you can go to the manufacturer's site, look up the MIB for that model, and see, well, what can I monitor? Can I get my tier 1 help desk an alert when the big 1,000-sheet trays are starting to run out of paper? Sure. I can actually show you that real quick under the counter. You can see that our studio color is probably this one. So our total printed sheets for that one are 120,902. And that's in about 9 months or so. We do a lot of printing. We do a lot of book design. Yes?
Can you drill into that and see the users who have printed how many pages?
So the question was, can you drill into that and see the users who have printed how many pages? The answer is, again, kinda. It all depends on that MIB. So if this is something, so for instance, these Ricohs run a specific software box next to them that's based on Windows, you could probably extend the SNMP agent on that box with some script that let you graph or do something else with that. But natively, depends on the printer. So none of the printers we have will do that. That sometimes is more of a function for something like PaperCut or centralized print server. But it depends, all depends. I want to show real quick the add device screen. Because this is pretty much the easiest add device screen of any of the monitoring softwares that we've ever used. You put in a host name, you select your protocol version, and you select your community, or in the case of v3, it'll prompt you for the username and then for the encryption key. You hit add, 10 minutes later, it's gone through its auto discovery, and it started to pull the device, and it starts graphing. All you have to do is fill in those 3 pieces of information and leave it alone. That's it. There is one more feature here that we don't use at Partners and Simons right now that may be handy for those of you who have a bigger data center or switch config switch deployment. And that is that it can actually do network auto discovery. So if you can define inside of the configuration files for Observium, you can say, all right, here's a list of 10 or 15 different community strings that we use depending on what the device is. Here's an IP range, and what it'll do is it'll use CDFS and LLDP, and it'll actually discover who is on your network. And it'll go through and it'll say, oh, I haven't seen this device before. What's your host name? Get that sys location, get that sys name, try the community strings. If one works, it adds it, auto-discovers it, and graphs it. So you could actually set this up in an environment where SNMP is enabled on every device, set it to auto-discover, and an hour later, you've got a fully populated monitoring system with all of your graphs starting to draw. Super, super, super powerful. There are, I should mention before we go to questions, there are 2 versions of this. There's a free community version. It's open source and releases about every 6 months or so. There's also a second version of this, which is called the Professional Edition. That contains the alerts, which we're about to look at. Get your special Brexit discount, because this is priced in pounds sterling, so it's 150 pounds a year, which is pretty cheap when you look at a lot of the price-benefit analysis between this and a lot of the other commercial tools. The big difference, as always, is support. If you're someone who likes to tinker and you maybe know a little bit of PHP and you don't need an instant production fix, a project like this is going to be great. They do have support email, but it's not going to be like the major production vendors that you might be used to. Let's go over alerts real quick, and then we will do Q&A. So the way Observium does alerts is it uses something called checkers. And checkers are kind of genericized criteria for alerts. And then you apply those checkers to the different entities or hosts or agents that you want. So for instance, let's take a look at the toner one, since we were just talking about printers. You can see that we have all of our printers here. And we're saying any metric that's of type printer supply, so that would be things like the waste toner bottle, fuser drums, fuser kits for the HP, laser jets, toner. If any of those types have a supply that's less than or equal to 1% on any device in our system, send us an alert. So now we have some custom ones for our color printer, because it takes us a week to get printers to get the toner sometime. But for the most part, when it's 1%, we always want to know, because that means someone's about to call us and say, I can't print. We want to catch that before it happens. And again, we've got our historical data there as well. We can also set things, for instance, to our main server, which used to be just called server. Nice and simple naming scheme there. We can say any of the storage entities that SNMP is sending back, if there's less than 100 gigabytes free, or maybe a certain percentage, and your host name is the same as this, and you can even say the description. So we can say, we don't care about /var or /etc. We only care about /mount and /lib, or the exact opposite way around. The entity matches and device matches also support standard regex. So you can write pretty much any test in there to say which device your alert should apply to and which pieces of that device it should be alerting on. When it comes to targeting alerts, remember we were talking about they need to be targeted, they need to be actionable. So we've just seen our threshold. We've just seen that we can make impact and cause-based alerts. And now you can see that there's contacts in here. We can target the alerts depending on who they should go to. So for us, it's pretty simple. There's only 2 of us IT guys. There's me and there's Lee, who's my boss. Hi, Lee. You can see that there's actually different totals here. There's 19 alerts that go to me. There's 14 alerts that go to Lee. And there's 20 of them that go to our common Slack channel. A lot of the Slack stuff is the littler stuff, things like toner and whatnot, things that, it's not production critical, whereas these 14 and 19 are production critical things. They're dev systems. They're things we're going to get asked about right away. And you can kind of figure out that contact however you like, whether that's a group email, whether that's something like PagerDuty, whether you set it up like this, push to Slack, HipChat, whatever notification system makes sense for you is how you're going to do that. I believe we have about 12 minutes left. Let's run through some Q&A real quick. And I'm going to try this. I'm not a good throw, so. Oh, little to the right. Sorry about that.
Hi. Quick question. When I first started getting into SNMP stuff, one of the things that always confused me, and I'm still trying to wrap my head around, is when you're dealing with devices, the MIBs aren't in what you're trying to pull from, and so importing and getting those and where to put them and things like that.
Sure. So the question is about importing MIBs. So every daemon and every manager has a specific MIB directory. Now this is something you can set in your configuration file, or it can be passed as a runtime option when you launch the daemon. And you can actually just grab, so for instance, those Ricoh printer MIBs, you can actually just download them from Ricoh, put them in the directory, and at that point, whatever SNMP daemon tool manager you're using is going to be aware of that. So really all you need to do is put them in that directory, pass the directory, and that's it. As long as you've got them in the proper place in the tree and you're referencing where they are in the tree, you're good. So for instance, the copier, Ricoh's going to have its own organization ID number, like the DoD was, I think, 6. They'll have their own number. Just make sure that number's correct. You can monitor. Any other questions? All right. Thank you, guys. Appreciate you coming in today, and have a good rest of your time.